All right, so we've got this and we're looking at these two. So we can see that neither one of them are exactly normal. Will we go ahead and say that this is approximately normal because there's no big non-normal things, no big outliers. So even though these don't look real normal, we're going to say that this is okay, and we're going to go ahead and proceed with the T procedures. So if we want to go ahead and go through our T procedures, we've got to have some hypotheses. So we're going to start with our H naught. And our H naught, remember, is always the hypothesis for no difference or no change. So what we're saying is that the calcium is not going to cause a difference. So my group 1, I'm calling it mu1. It should equal mu2. If there is no change, those two means should be different. But now we're ready for our alternative. And what we think is going to happen is that the mean diastolic blood pressure is going to decrease. Well, remember in the problem, it says that a decrease is represented by a positive number. So we should say here that mu1 will be greater than mu2. So once you have set up everything, then you're ready to go ahead and conduct the test. So if we're going to conduct the test, we are going to go to our calculator. All right, so we're going to go to our calculator and we're going to go to our stat and over to our test. And we have to look at the 2-sample t-test. So this is 4. So you're going to say we're going to do this from data because we have our data in our calculator. So we're going to say that list 1, group 1 is in list 1, group 2 is in list 2. Each one should have a frequency of 1 and we have a greater than test. The next thing it's going to ask you on the 2-sample T procedure is if you want to pool your data. And I'm going to tell you, and we'll talk more about pooling later, but unless you are 100% sure that you should pool, you never pool your data. Never, ever, ever. So if in doubt, don't pool. Okay? So we're not going to pool our data, so we're going to say no there. And then it's going to ask us to calculate. So we're going to calculate what we got here, and we're going to report our important information. We have a T statistic, which is about 1.604. We have a degrees of freedom of about 15.591. We have a p-value of about 0.064. Once you've got that information, then you are ready to decide what this test told you. So you're going to look at your p-value, and your p-value is 0.064. That is not significant at the 5% level. So we would say that we do not have enough evidence to reject H naught. So we're going to then interpret our results. So we'll say with a p-value of 0.064, this result is not significant at the 0.05 level. Therefore, we fail to reject H naught in favor of HA and believe that calcium does not lower diastolic blood pressure in black men. And so we've gone through the whole procedure from start to finish, and this is what your result should look like. Now, whenever we're doing a 2-sample procedure, we can still use the data in 2 different ways. So let's talk about how we can use the data. Option 1, we can use procedures based on the statistic T with critical values from a t-distribution with degrees of freedom computed from data. And that's what we did. We used the information computed from the data. When we do it this way, the degrees of freedom are generally not a whole number. And I will tell you that this is the most accurate way to get an approximation of your t value because of the fact that we are not having to do anything different. So that's the first way. So oftentimes when we're using our calculator, we are going to just let the calculator give us our degrees of freedom, because in the two sample, you really can't do it by yourself. However, the other option is to use procedures based on the statistic t with critical values from the t-distribution with degrees of freedom equal to the smaller of N1 minus 1 or N2 minus 1. Look at each of your samples. Look at N1, take away 1. Look at N2, take away 1. Whichever one of those is the smaller, you would use that as your degrees of freedom. Now, this is always erring on the side of caution, and you will always get conservative results. So just make sure that you're aware that this is the most accurate. If we did this on the test we were just doing, the degrees of freedom would have been 9. When we did it with the calculator, we got 15.5. So that's really going to be a more accurate estimation. So usually in the two sample, we're going to just use our calculator to come up with our values. So now let's talk about officially the two sample procedures. So we can do one, a confidence interval. With two samples for mu1 minus mu2. And the way that we do that is we take x bar 1 minus x bar 2 plus and minus your t star onto the square root of s1 over n1, but s1 is squared, plus s2 squared over n2. So that's how you find your t star, or I mean your confidence interval, and we still use t star in the book just like we had to do before. To test hypotheses, H naught is mu1 equals mu2. That's the hypothesis of no change or no difference. Then we find our t statistic by taking x bar 1 minus x bar 2, sample mean of 1 minus sample mean of 2, over the square root of s1 squared over n1 plus s2 squared over n2. And on these, that will tell us our p-value from a TK distribution. Okay?